Hello, my friend. Welcome to OK Mavin, the one-stop junction for your technical enlightenment. Today, we will learn together the intricacies involved in the simulation of an e-drone. I have tried to keep this video short and close-packed with minute details. For the detailed explanation of a particular topic, you can post your queries in the comment section below. Do like and subscribe the channel for relevant videos and share this with your friends if you find it informative. First, an e-drone aims to maneuver itself quickly with maximum precision possible in order to complete the tasks assigned to the drone. e-Yantra expects the participants to know the working of a drone as well as to program the drone to achieve the aim described earlier. Being a participant in the previous year myself, I know some of you might be wondering how to proceed with the task and how to take it to completion in the given short time frame. So I would suggest watch this video carefully as I'll be explaining the proper strategy to follow for completing tasks effectively. Last year, the drone sub-theme required the participants to stabilize the drone at a given space coordinate, to maneuver it to multiple space coordinates within minimum time and maximum precision. This task required us to learn about the PID tuning and to implement it with a Python script. Now, what is PID tuning? PID stands for proportional, integral, and derivative. A PID controller is a device which is a chain of proportional, integral, and derivative parameters of a system. In other words, we can control the movement of a body inside a system by taking in consideration its input parameters and output parameters. This is achieved by creating a feedback loop in the system. This concept can be better understood while looking at the diagram. Now Kp, Ki, and Kd are the coefficients of proportional, integral, and derivative parameters respectively. Varying the values of Kp, Ki, and Kd in a proper way will eventually result in the stabilization of the body, drone in our case, in the system. Some of you might be wondering, how do we get to know what should be the values of Kp, Ki, and Kd? Well, I'll be covering this topic in the end. For the participants who are wondering whether you need to simulate the system in MATLAB to use the concepts of PID effectively, well, my answer will be a big no. This is because simulation in MATLAB to achieve the PID control is possible only when we have some equation describing the environment, which in our case is not provided by e-Yantra. So what should be our approach? Well, just know the basics of PID control which I am telling you in this video and focus on the application of this concept through your script. Do not, I repeat, do not delve mathematical concepts of PID tuning, as that would not help you in this limited time frame and only result in your wasted time. The main focus should be on writing an efficient code and doing multiple iterations to achieve your desired precision. Now coming to Kp, Ki, and Kd. How do these coefficients affect the drone motion in general? As you can see, the Kp value is directly multiplied with the error function. Now for those who have successfully completed the task 0 might be well aware of the concept of error function by now. When I say Kp is multiplied with error function e of t, it means that the proportional parameter of PID will reduce once the error function reduces. In other words, once the drone starts approaching its endpoint, the error decreases eventually, thereby decreasing the speed of the drone. Similarly, for the Ki value, we can see that it is multiplied to the integral of the error function. This means that we have to add the value of error function in each step to a variable, say sum, and we have to use this overall sum of errors to multiply with Ki for our integral parameter. In other words, our drone will oscillate across the given space coordinate until it finally stabilizes. Hence, I would like all of you to keep in mind that integral parameter is the main cause of delayed stability because it induces oscillation if value of Ki is high. So make sure that you keep the value of ki low in your Python program. Ki is just used for accelerated motion of your drone towards the target. But if other parameters are not varied properly, it will induce instability in the system as described earlier. Now coming to the kd value. It is the derivative of the error function with respect to time. You can understand its physical aspect by looking at the response graph obtained after PID tuning. As you can see, the derivative graph never really approaches zero or a baseline. kd value adds into the stability of the system. It basically reduces the overshoot of the drone from our desired endpoint. Here, I hope that your basics related to Kp, Ki and Kd must be clear. If you are anywhere near comfortable than before, then great. Now we can advance to the next step. How to implement these concepts in our Python script. Well, e-Yantra provides the participants with a tool called PID tuning script. What is this exactly? This is a GUI application which helps us to tune the Kp, Ki and Kd parameters of our drone manually by hit and trial method. I am going to explain the concepts sequentially now. Number 1. We need to first write a Python script which has Kp, Ki and Kd as variables which are subsequently used to implement the formula for proportional, integral and derivative parameters. Please do not ask for codes or scripts in the comment section. Maintain the code of conduct expected by e-Yantra. Number 2. We have to find the values of Kp, Ki and Kd using the tool now. For that, you have to run your script and in another terminal launch the PID tuning simultaneously using ROS launch or ROS run command. Note that your drone won't maneuver until you have set some values for Kp, Ki and Kd. Now number 3. How to know whether the values are stabilizing the system or not. For this, we have to install a tool called plot juggler. This tool shows us the variation of PID parameters with time during the drone's motion. To install this tool, use the command sudo snap install plot juggler. Now number 4. Repeat the step 2 and iterate through different values of Kp, Ki and Kd and check if the graph is within the allowed error limits or not. Step number 5. Since it is a manual tuning method, the focal point here lies in teamwork. Make sure each member is iterating and implementing the script in separate systems to achieve precision in minimum time. Number 6. Keep aside a minimum of 2 days for iteration purpose. Maximum marks will be gained by team having a modular script and short stabilization time of the drone. Now I am assuming you all must be knowing how to vary roll pitch and yaw. If not, comment below and I'll make a video explaining that concept too. I think by now you all must be well aware of the underlying concepts of this task. Please post your queries and doubts in the comment section below without violating ethics of the competition. Like, share and make sure you hit that subscribe button for more such content in the future. Thanks for watching. Good luck to you and your team, buddy. Okay, Mavin, over and out.